Hello friends, I am Banu Pratap Singh. Welcome to all of you in this session of thermodynamics. So let's start with our session. First of all, overview of this session. In this session, we will have definition of thermodynamics. Second, we will cover what is system and surrounding. Third is types of system, different types of approaches in thermodynamics. Next, we will cover properties of the system. Next, state of the system. What is thermodynamic cycle? And in the last, we will cover zeroth law of thermodynamics. What is thermodynamics? Thermodynamics consists two words. First is thermo, second is dynamics. Thermo means heat, dynamics means motion, means heat in motion. So the definition of thermodynamics is it is the science of energy transfer and its effect on the properties of the system. In thermodynamics, what is system? System is a region in space upon which the study is focused. What is surrounding? Anything external to the system is called as surrounding, and the surfaces which separate system to the surrounding is called as boundaries. Here we have a system. These are called as boundaries. So boundaries differentiate system to the surrounding. Different types of example in thermodynamics are rise of temperature in kettle on heating, cooling of a room on a hot humid day, heat up of our room on a cold winter night. Next is types of system. In thermodynamics, we have three types of system. First is closed system. Closed system are those systems in which no mass is permitted to cross the boundary of a system. But in closed system, heat and work can enter or leave the system boundary. Suppose we have a system. In this system, no mass can enter, but heat as well as work can enter or leave the boundary. Next is open system. In thermodynamics, maximum systems are open system. Open system are those systems in which mass is allowed to enter the system boundary. In open system, mass as well as heat and work can enter or leave the system's boundary. So example of open system can be a piston cylinder arrangement with valves. In closed system, a piston cylinder arrangement without valves. Here in the system, mass can in, mass can go out, and heat can go out, heat can go in. Next is isolated system. Isolated system are those systems in which there is no interaction between system and surrounding. It means a fixed mass is in the system and there is no mass and energy transfer across the system boundary. Example of isolated system is a hot coffee in a well insulated flask. We can differentiate our system. First is closed system, another is open system, and third is isolated system. Here we have mass, here we have work or heat. In closed system, mass cannot enter to the system's boundary, but work and heat can go in or can go out from the system's boundary. In open system, mass as well as heat can enter to a system's boundary. In isolated, mass is not allowed to enter system boundary as well as heat and work cannot enter to the system's boundary. Next is different types of approaches in thermodynamics. What are the different types of approaches? First approach is macroscopic approach. Macroscopic approach are those approach in which behavior of individual molecule is not taken into consideration, but the average behavior of molecule is taken into consideration. Example of this type of approaches is temperature and pressure measurement of a room. Next is microscopic approach. Micro means very small. In microscopic approach, behavior of individual molecule is taken into consideration. Example of microscopic approach is measurement of density at higher altitudes. Next is properties of the system. Properties are the characteristics of the system. In thermodynamics, there are two types of properties. First is intensive property. Intensive, independent. Intensive properties are those properties in which value is independent of size or extent. Example is pressure, temperature, density, viscosity, thermal conductivity. They are not dependent on the size of the system. Next is extensive property. Extensive properties are those properties whose value is dependent on the size or extent. Example is mass, volume. Next is specific extensive properties. It is the value of extensive property per unit mass of the system. Example is specific volume. And ratio of two extensive properties will be a intensive property. Here we see, first we will look for the intensive and extensive property. Suppose we have a system with mass m, volume v, temperature T and pressure P. Suppose we reduce the size of system by half. The new mass will be m by 2, new volume will be v by 2. But the temperature and the pressure of the system will remain same. So here we see temperature and pressure are not dependent on the size. They are independent of size. So these are intensive property and these two are extensive properties. Next is ratio of two extensive property will be a intensive property. Here we see like specific volume is equal to mass per unit volume. Volume is a extensive property and mass is also a extensive property. But the specific volume will be a intensive property. Next is equilibrium in thermodynamics. Equilibrium is the state of balance, and in equilibrium state there is no unbalanced potential, means no driving force within the system. So in thermodynamics we have different types of equilibrium like thermal equilibrium. If the temperature is same throughout the entire system, the system will be said in a thermodynamic equilibrium. Next is mechanical equilibrium. Mechanical equilibrium deals with pressure and force. If there is no change in pressure at any point of the system will be said in mechanical equilibrium. Next is phase equilibrium. If system involves two phases and when the mass of each phase reaches an equilibrium level and stay there. Last is chemical equilibrium condition. Chemical equilibrium condition deal with chemical reaction. If the chemical composition of the system does not change with time, means no chemical reaction occur in the system. System will be said in chemical equilibrium. Next is what is path and what is a process. The succession of state passed through during a change of state is called as path of the system. A system is said to go through a process if it goes through a series of change in state. A system may undergo change in some of its properties or all of its properties. Next is different type of processes in thermodynamics. First is isothermal process. Iso means constant. Isothermal processes are those processes in which temperature is constant. Next is isobaric. Those processes in which pressure is constant. Similarly, isochoric processes are those processes in which volume is constant. Isentropic processes are those processes in which entropy is constant. Isenthalpic processes are those processes in which enthalpy is constant. Last is adiabatic process. Adiabatic processes are those processes in which no heat transfer from the system or to the system. What are reversible and irreversible processes? A process is said to be a reversible process if when reverse in direction follows the same path without leaving any effect on system and surrounding, and a process which is not reversible will be called as a irreversible process. Reversible processes are the most efficient processes in thermodynamics. In the next sessions, we will see how the reversible processes are most efficient processes. What is quasi-static process? If a process which is carried out in a very slow manner is known as quasi-static process. Quasi-static, very slow. In quasi-static process, all state of the system passes through are equilibrium states. Frictionless quasi-static process will be a reversible process. What is a thermodynamic cycle? A system is said to have undergone a cycle if the initial and final points are same. For a cycle, change in property is equal to 0. It is because its initial and final point are same. Next is phase. It is a quantity of mass that is homogeneous throughout in chemical composition, physical structure. Example of phases are solid, liquid, vapor, gas. Next is zeroth law of thermodynamics. If two systems, suppose system A and system B, are in thermal equilibrium with a third system, say C, separately, that A and C are in thermal equilibrium condition, B and C are in thermal equilibrium condition, then they are in thermal equilibrium themselves. Say A and B are in thermal equilibrium, B and C are in thermal equilibrium, then A, B and C will be in thermal equilibrium in themselves. In this session, we have covered definition of thermodynamics, system and surroundings, what are boundaries, different types of systems, different types of approaches used in thermodynamics, properties of the system, what is state of the system, path, a process, thermodynamic cycle, and zeroth law. For more videos and update, subscribe to our YouTube channel HitBullsEye or log into website hitbullseye.com. Thank you.